Today I want to muse about complexity and just talk about where does complexity hide at all, because complexity is something that's of interest to us, especially as assurance folks, because we seem to correlate complexity with potential issues and risks. Now, is complexity always about something about size or scale? We normally tend to associate it with it. Something is big, we think it's complex. Something has scaled, we think it is complex. But do realize that probably true complexity lies not just in the context of scale or size, it's really about the interactions. If something is highly interactive inside, that means various elements that make up the system, which are deeply coupled, not just the individual components, but the way they work together. If that is so, then maybe it is intrinsically fundamentally complex. So anything that can be seen as interacting, deeply connected, has a potential to be perceived as complex and therefore not limited to size or scale. Right? So truly it's not about how much there is. It is really about how tightly it is coupled. Whether it is the building blocks, whether it is the ideas, whether it is the states, whether it is things beyond code. Therefore, how ubiquitous, how subtle it behaves, and how sometimes it invisibly shifts, which means we don't understand what's happening. And therefore, it gives a sense, man, this is complex. Somehow I found that in one of the recent, I think the latest update of Mac OS, where I think one of the features that I used to do very frequently was to do sharing. So if I had, let's say, a keynote, which is equivalent of PowerPoint, or the pages, which is the equivalent of Microsoft Doc, any documentation piece, I would write out a document, be it a presentation document, and I would go to file and then say share, and I can just send it to somebody as an email, and it'll tell me, do you want to send it as a pages document or a Word document or a PDF document? I will convert. It seemed to be easy. I've used that many, many years. Now, after the recent upgrade in the Mac OS, I'm horribly confused. It seems to be mentally very complex to me, and I'm still getting the hang of it. So what's the problem? The problem is very deeply coupled with a lot of other features which are sitting there, making that particular menu a little irritating because it's not anymore. It has so many options to choose from. So one, from the way it is presented, it is visually complex. And the way it is internally set up in terms of how the various features interact, seemingly irritating. So mentally, I find that it's a very severe amount of cognitive overload for me. I'm not saying that the internal code is severely complex. I guess the way they have tried to position it in terms of interactions of these various features in one piece is just not right for me. I'm sure there are many, many examples that you probably can relate to. So one of my friends, when I posted about this, he actually said, hey, Ashok, maybe you want to talk about this. And then he gave me 3 points. And I thought I would share that with you, which I think is very pertinent to our discussion. Is complexity in the system, or is it complexity in how we perceive? So if my perception of something is hard, simply because it requires a lot of cognitive load, then it is complex. It is not the volume. It is not of how many things I do. But if I find it very intricate, right, it might be I could possibly take, let's say the task is about reading a book, and maybe the book is 100 pages long. And let's say I'm fairly accustomed to reading, and maybe therefore 100 pages shouldn't sound too big, right? It's not a 1,000-page book. So the volume-wise seems very less. But the same 100 pages, let's say it's got fairly rich English, convoluted way of explaining a few things. then what happens is the same 100 pages become very torturous. And that's really cognitive overload. So my perception changes, right? The second kind of stuff, that the second point that you mentioned, is where is the complexity? Is it my understanding of the subject matter? So my lack of understanding of the subject matter. So if I don't know as much, if I don't know something broad and deep about that particular subject, then for me it is complex. So truly speaking, complexity is not an inherent trait of the system. It is not a fundamental attribute per se. It is not simply about the volume and the size and the scale. It is really about how my perception of the system is. And therefore, there is a space that is up there. There is a system on one side and there is me, and that's where it hides. And the whole purpose is we're trying to figure out how to navigate this, right? As a builder, as an analyzer, as a validator, and as sometimes a user, right? So these are 3 points that Srini Kulkarni suggested as when I posted it on LinkedIn about the webinar. I thought it was very interesting that that I should probably share. So it's not like fundamentally saying, yeah, I know that we could write a convoluted piece of code. We could have a very rich set of feature and therefore make it less simple. There is a part to that. But if I'm able to unwrap it, if I'm able to understand it, if I know, then it doesn't become fundamentally very complex. Keeping that in mind, let's look at where does this hide. So we started with the term as where does complexity hide? And so where is it? Well, maybe is it in the flows of data? So is it in complicated data flows, which go from here, gets processed there, it goes. So is it in the context of data and data flows that you're not able to see, and therefore the complexity is kind of hidden? And that is why sometimes when we test, we can't quite obviously, like all we know, we can't take a purely black box approach. We need to understand certain internal structural pieces. Could be the way it is composed, in the way data flows, in the way system sends messages and how they kind of control flows. So we know that there is data flow, there's control flows. And if you go back to software engineering and read about it in terms of complexity, you will find data flow complexity, control flow complexity, and so on. So one place where it hides certainly is in the flow of data. Second place where it hides, system states. So what's a state? A state is normally a representation where we say at a point in time, this is how you can characterize a system. And so if the system thinks it is in a particular state, or for some accidental reason it thinks, but we have moved along, then possibly it would misbehave. One interesting problem that I encountered today when I was making this presentation, I was cutting and pasting certain text into a blank slide. And what it did is when I pasted it, it converted into a table and then showed me as rows and columns with text in between. It thought the text that I had is a comma separated file. I certainly didn't give it comma separated file. All I did was to cut and paste. So I don't know, does the system think that it was in a prior state, maybe in a prior slide where I'd edited a table, and then was it stuck in that groove, and therefore when I pasted it thinking it is a table which is invisible. I could see it, right? I don't know, maybe, but I just wanted to tell you that yeah, if there are system states and the system is not transitioned properly, then we know it has a problem, which I know we might encounter when we have a good state machine in place. We take a lot of effort to do it, but sometimes it gets into states and not able to come out. And that's why we call it hang, right? So when you say hang, it simply means it's not able to come out of a state, and therefore it's stuck, and that's the end of it. I'm sure when multi-threaded pieces of code, we kind of appreciate this better, the timing and the sequence, not the logic. I had a multi-threaded piece, so I spun off multiple threads, and maybe there was a race condition, maybe there was a synchronization, maybe because of timing sequence. One ran fast, one ran slow, and because of that, a race condition happened, and boof, you lose data, or something really bad happens. which I really encountered, which I really can remember maybe about 3 decades ago when I was building an embedded system, and I had two tasks, and I was building a library to help implement something about the inter-process communication layer for an application. So I had like an application IPC, which I was building many decades ago on a small embedded system, which was very limited. So we're talking about 64 kilobytes and 128 kilobytes of RAM. So it has to be super efficient. And I remember doing that in C. And there was a point when this IPC would actually be called by many applications, and it would transfer data. And it would be very multi-threaded. Problem was it didn't work sometimes. Sometimes it worked, and I could put a debug statement because it was multi-threaded. And therefore, after some enormous amount of code review and hypothesizing situations, I found it was a race condition. And that was complex because it cost me 2 nights to fix that problem, to analyze. And all it was a bit of a race condition due to speed and synchronization went all right. That's the hiding because of temporal aspect, right? This sometimes we see in configurations. Sometimes you set up a configuration, you don't know what the configuration does, alter some internal behavior, and you don't know what it did. And therefore, the complexity hides in some settings of configuration, which you simply don't know, right? A very crude, simple example that I have to illustrate this a long back. I think there was a software that we were validating, and it had an opening screen which said, "What is the size of your display?" So I guess it expected it to be like 1920 or 1024 or some number like that. And of course, we're all testers, so we just tried to experiment with a number called 0. It was a setting. And 0 display means the display will vanish because it's 0 pixels, right? And then that was the end of the software. Now, and I thought I'll reboot, I'll come back, it'll show the same screen. No, it was permanently set, so I had to reinstall. So, it's kind of a stupid configuration, but I didn't realize how bad it was, right? It showed up as a bug, but sometimes it doesn't show up, right? It just, configurations alter the system so badly. So, just to give you an example of the first one of a data flow very recently, I think about a week or 2 ago, that I was using the GPS system of my cycling navigator, and I had downloaded into it 1,000-kilometer GPX file, which is basically a map, because I was actually going on a 1,000-kilometer ride on a cycle. Now, so what it does is basically navigates. It just tells you turn left here, turn right there. And promptly for a lot of us, after about, I think, 10-15 kilometers, the system stopped responding and we were stuck. And why? Because somewhere in the deep down, there was a significant amount of volume of data simply because it was 1,000 kilometers, and second, because it had too many turns. And more the number of turns, more the number of floors, and so on. And the system kind of locked up. So it was a dead end. So we had to reboot, break that file into smaller parts, and then go through this piece and so on and so forth. So, I don't know why they didn't think of it, but then it was one of those mysterious complex pieces. So, the funny thing is it hurts. So where does it hide? It hides in data flows, it hides in system states, it hides in timing aspects or temporal aspects, it hides in configurations, and sometimes it hides in behaviors that I don't expect. So the 0 part of it and configuration part of it are all unexpected behaviors, and therefore it hides. So let's probably dig into a little more detail in each one of them and probably take a look at and muse about what do they mean. So where does it hide? And we all know about this. We're all good testers. We know that stuff, and that's really about assumption. As a developer, I assume that this will be on, the system will be up, the flag will be set, the user will follow this particular path. And so those assumptions are the hidden complexity, right? Because you don't make it explicit, and therefore we really don't know how the system behaves. Sometimes we assume, which we normally do, that's the system assumption. This is your assumption, right? You assume that the spec is well set. it's correct. That some configurations won't change. Somebody won't come at the backend and quietly change the configuration file or copy something up. Or we assume sometimes, the environment that I am testing on is probably the staging or the production environment. And there is a small hitch. They are not exactly the same in certain aspects. So I am sure there are many more illustrations, but the key idea here is assumption. So the complexity hides because it's a camouflage. So the act of assumption. So the act of attempting to explicitly figure out, which is what we do as test folks. We probe. We want to make certain things more visible, more explicit. And therefore, we try to minimize casual assumptions, which could result in a system assuming, because that's the way we implemented it, or we assume as a part of before or after implementation, right? So keeping in mind that, it's a beautiful camouflage. You won't notice it until you until you encounter the problem. Sometimes the complexity is not because of just the code. The code might be long, the code might be intricate. That doesn't simply mean the code is complex, right? It's not because of unreachable code, not unreadable code, unreachable code. I'm sorry for that. The complexity is probably the order, the dependencies, the triggers. It's not just, it's a fairly complex piece of code. It's not the control structure per se of the code. It's not the design complexity behind that alone. It's sometimes the intricate order or the interesting interdependencies or the invisible triggers behind some change that happens. So the complexity happens because of the flow. And that we know is called coupling, entanglement. When in software complexity we use a word, it's called coupling and cohesion. We all like to say that we should decouple, we should modularize, we should be more cohesive. And there are many variations of code complexity. Right? So all we're saying is from a code aspect, we know code complexity. But it may not be only because of code, right? It could also be because of the flow. Some order is wrong. You did this in a slightly different order, system malfunctions. I kind of saw that in some of these softwares where they were rich software, very rich, because you could do a set of operations in different parts of the software. There was a fairly rich UI, and in that UI you could do this, and you could go to another UI and do something, the same one in a different context, and so on. So it is very, very rich UI. But then the problem was, it would sometimes malfunction simply because it didn't understand certain dependencies and certain orders, because the same thing was being possible in different screens, in different facets. Why? Because it was deeply coupled. And therefore, you thought that the same features invoked in one screen, it should work the same way in another part of the software, maybe in another set of screens. It didn't. It is fundamentally entangled. So that's the catch that you have to worry about, right? So it's in the flow. So moving on from the notion of assumption to the entanglement and going into the people aspect, it's a social complexity. What do you mean by social complexity? Only few of us know it. Only I know it. Only you know it. And therefore, it's not public knowledge. Behavior sometimes is undocumented. Maybe we made some decisions, let's fix it this way, let's implement it this way, but we don't really possibly share it in some form or fashion with the others. So it's forgotten. And therefore, what happens? Complexity thrives because knowledge isn't shared. Right? It's seemingly complex. I think the simplest example is dealing with government systems, right? You think it's complex, so getting a license is complex. So you think it's complex, so you find some driving agency and give some money and you get it fixed. It actually is straightforward. Or maybe you want to get some property document. I don't know how to do that, so I'll find some guy and he tells you it'll for 25,000 rupees, he will fix that for you. He will get that for you. And you say, okay. Why? Because we don't know. Knowledge isn't shared. In a similar kind of a context, we're talking in the context of software too. There is social complexity. I don't know, you know, and therefore it's problematic. And therefore, sometimes I do things maybe made on some assumptions and it goofs. I remember an interesting example of many years ago when I was renewing my passport. I think that was the first time that the software is introduced and we could do an online passport. So remember, we're talking maybe a decade and a little over a decade. And I was probably one of the first guys to use that software. Of course, it was very buggy. That's a different story. But leave aside all that piece. I did the online piece of submitting the information, setting up the appointment, and went into the passport office. And of course, they had to take the picture, do the biometric and all that stuff. So they did all that. And then they were all set to print, right? And then it showed me, I live in Bangalore and my district is Bangalore. So it said Bangalore, because I know that first word city and second word. But it didn't say Bangalore city, Bangalore district. It said Bangalore. And then I said, look, if you print this in a passport, when you say Bangalore, somebody will think I'm holding a, not a genuine passport. It doesn't seem right. And that guy was stuck because that's how the software was printing it. And I told him, this doesn't seem right, sir. It would get me into trouble. And the guy didn't know what to do. And like me, there were a few other people who had the same problem. And then one guy stood up with face smiling and beaming, and he said, oh, anybody has this problem? Because all these guys were asking how to fix this. And then he says, don't worry, I know how to fix it. So he came and he used some magical keys, because all they were trying to do is to delete that information and retype the information. And the system was not taking the new information. It was deleting, it was showing the delete, but it was not accepting it. And this guy did some magic key, some magic set of keys he pressed, and lo and behold, everything worked. Now, that's an example of what you can see here. That knowledge is not public. Now, this is in the context of, an operational aspect. The same thing could occur in the building aspect. The developer didn't tell you that, hey, here I have a flag, you must change it before you do it. Or this is how it is. This assumes some of these things, you have to be careful. Or we made this decision long back, I hope you remember it, and therefore this won't work this way. Right? That's the notion of social complexity. So it's nothing to do with code. It's nothing to do with assumption. Ultimately, when you look at complexity and confidence, when we don't understand enough about a complexity, we either over-test or under-test. And neither of them is a problem, right? Because we don't understand. So we think it's too easy, or we over-text because we need to do a lot of stuff, right? And therefore, it doesn't help very much. And therefore, what we're trying to do is trying to sense complexity, right? We're trying to sense, and the only way to sense probably is to probe deeper and wider. And if I didn't know what it takes, how do I? So if somebody told me, oh, I want you to test a search engine, and all I see is just a little text which says search string, enter your search string. And I don't really understand. I think it's okay. Or just a string, right? So I'll put all variations of strings and maybe put things like plus and so on and so forth. But no, I don't think it's that straightforward, because search engine is not just about a bunch of strings. It's about crawling, assimilating, packaging, servicing the request. To do it fast, maybe have various copies of it in various parts of the world. So there is a whole lot of hardcore infrastructure that is up there, which allows us to search in any of the search engines today. And if I didn't know this complexity, I become either overconfident or underconfident, and therefore I don't know. But if I started probing, how does it work? How is it structured? What happens? What happens to my request? How is it set up? How would the system constantly learn? Then I'm trying to sense the complexity. I'm not trying to evaluate. I'm just starting to probe. And therefore, the idea of uncovering complexity with probing is what probably makes a lot of sense. We're constantly trying to probe to get a better handle on system's complexity. So we're trying to ask, what happens if I do this way, reverse the order? What other flows happen? If this falls, if this thing falls silently, this the system doesn't work, who notices? What happens when this configuration flag is not set, and so on and so on, right? So what we're really saying is we're trying to understand the system complexity, and we can't, what we're trying to do is only probe. And in the context of probing, we hopefully get a better understanding, and therefore the cognitive load becomes better. Our perception becomes better. We make less assumptions, and that's how what is hidden gets slowly surfaced. So it's not really about breaking the system. It is about learning what it resists revealing. Because remember, we started the whole idea with complexity hides, and we are probing to find out where it is hiding and therefore get a better handle. And therefore, in some sense, all we're trying to do is to learn and understand and so on by the act of probing. So in a nutshell, complexity is not a flaw. It's not that everything can be simple, right? I mean, there is fundamental complexity, but the question is, can you handle it? Everything ultimately, when we understand, is fundamentally simple. But then there is an inherent notion of complexity, right? It is part of building anything meaningful. A human system is fundamentally inherently complex. Any systems that we do today use is enormously complex. What you feel as ChatGPT today as an interface is probably enormously interesting and complex. The problem is, it's not that it's complex. The problem is not knowing where it lives, to understand where is the complexity, and therefore learn to appreciate, map it, and take care of it. So what really our job, maybe as assurance folks, builders, all of us, especially in assurance, is to shine a light on it, to make it not so hidden, to map it out, to know where it is, so that I can take care of it. And finally, sometimes embrace it. It's necessary, because that's when it can deliver a higher value, because it allows us to do more interesting things, right? And that's really what complexity and how it matters to us is. Our job really is shine a light, map it, and maybe embrace it. All we're trying to do is to find where it hides and look at it from various angles. Is it a social thing? Is it because of assumption? Is it because of a system? And so on and so on. Right? It by itself is not an attribute of the system. Thank you so much for joining us today.